Hi guys, welcome to my PPT presentation. I introduce myself. My name is Samadhan Kolekar. I am student of MIT Academy of Engineering Alandi, Pune, and I am from Civil Engineering Department in SY Tech. Today's PPT subject is Geotechnical Engineering. Today I discuss one of the important and interesting topic in geotechnical engineering, that is classification of soil. How soils are get classified? So basically, soil are get classified in three types. That is grain size classification, texture classification, and classification of soil by their uses. In this, before we go into detail, we see the index of our PPT. That is introduction, then needs, then we explain the first type of classification of soil, that is grain size classification. Then second type, that is textural classification of soil. Then their limitations. Then third type, that classification of soil by uses, and then by their remarks. So we start our presentation by the introduction. So what is definition of classification of soil? The arrangement of different soils with similar properties into group and subgroup based on their classific applications, called as a classification of soil. Number of classification systems have been proposed since the first quadrant of the second century. Now we going to move the need of classification of soil. In first, that is a classification of system represents in effect a language communication between engineers. Communication be become easier and clear understandable for engineers. Then second, it enable on to use the engineering experience of there. And the third, which is very important, that by knowing the soil classification, the engineer already has a fairly good and general idea of the way the soil will behave. We going to move the first type of soil classification, that is grain size classification. Grain size classification is depends on the size of soil. So basically the soil sizes are classified in the four type, that is gravel soil, sand soil, silt soil, and clay soil. There are four organizations having different limitations for different soil sizes. That first is Massachusetts Institute of Technology, that is MIT, US Department of Agriculture, that is USDA, American Association of Highway, State Highway and Transport Officials, that is ASTO, and United Soil Classification System. This table this table gives the different organizations, gives the different limitations for different size of grains. And first, the Massachusetts Institute of Technology gives the limitation that for gravel, that is greater 2 mm, for sand between 2 mm to 0.06 mm, for silt 0.06 mm, and clay less than 0.002 mm. And US Department of Agriculture gives the greater than 2 mm for gravel, 2 mm to 0.05 mm for sand, 0.05 for silt, and less than 0.002 for clay. Then American Association of State Highway and Transport Officials, that is ASTO, gives limitation that 76.22 mm for gravel, 2 mm to 0.075 mm for sand, and 0.075 for silt, and less than 0.005 for clay. And United Soil Classification System gives 76.2 to 4.75 mm for gravel, 4 to 0.075 for sand, and less than 0.075 for fine. You see, it is same for silt as well as clay. Now I move towards the next type of soil classification, that is textural classification. We start from their definition, that is soil are named after their principal components which are present in the that soil sample is called as a textural classification of soil. Some general terms, that is coarse textured, medium medium textured and fine textured. So what is coarse textured? The mixture of large soil plus small soil called as a coarse textured. Medium textured, that is present only small soil, and fine textured, that present only fine grained soil. Texture classification are refers from USDA, that is US Department of Agriculture, and for giving the or solving the texture for the soil sample, we need to solve a numerical by the helping of this diagram. So how this diagram helps to solve the numerical and get the real texture of soil, we see our in next slide. For getting the texture of soil sample, we need to solve a numerical which I explained earlier. For that there are some steps to solve the this numerical. So steps to solve: first, find amount of different soil in sample. Second, draw it on USDA pyramidal graph which I seen in before slide. And third is find the portion that intersection point is lies. So how we solve these numericals? We see by the one example. We see the one example how to solve the texture of soil sample. So first step, that is solve the amount of different soil in the soil sample. So here we take a different percentages of soil, that is gravel 11%, sand 56%, silt 21% and clay 12%. In these percentages we took the first two greater percentages, that is sand 56 and silt 21%, and these uh, these percentages we put on our triangular diagram. So first we put the 56% of sand on sand side, and second 21% of silk on the silk side, and getting the one intersection point which is lies in the sandy clay loam. So by the this numericals we see or we know that the soil sample is a sandy clay loam type of soil. There are the some limitations of the texture classification, that is first does not consider plasticity, means they are based on entirely on particle size distribution and does not consider plasticity, which to great extent influence and physical properties of soil, because the texture classification system do not take plasticity into account and are not totally indication for most engineering purposes. And the second, the two elaborate system used at the present are ASTU and USCS. Both systems take into account the size, particle distribution, and plasticity. In ASTU classification system is used most by the highway department. That is the third point. Means the ASTU classification system is used mostly the highway departments for making the highways. One of the important and last type of the classification of soil, that is classification by use. So classification of soil by use. It refers to ASTO classification system, that is acronym of American Association of State Highway and Transportation Officials. Basically, it is developed in the 1920 by US Bureau of Public Roads for the classification of soil for highway submerged use. Submerged means the footpath, and this system classifies soils in the group A or group B. So in the group A is made the pavement at all locations, but group B were not. It not maintained pavement to all locations. By this, the group B is deleted and group A is living. And further, the group A is divided into their 8 subgroups, that is A1 to A8. So there are some criteria to detect or to know what is the gravel size or grain size, that is in the fraction passing. If the fraction passing 75 mm sieve, it written on the number 10, which is 2 mm. If the sand, then fraction passing is number 10, use and written on the number 20. If the for in the case of silt and clay, the fraction passing, the number is 200 USC. And in the before textural classification, we see that they not consider plasticity, but in this type of classification, they refers or they considers the plasticity. The term silty is applied when the fine fraction of the soil have a plastic index of 10 or less. The term clade is applied when the fine fraction have a plasticity index of 11 or more. So here gives, and for that we required to do some test, that is grain size analysis, liquid limit and plastic limit. Now here the table that we see before. At a number 10 we see the 2 mm opening. At 2000 there is 0.075 opening. The table, that is general classification, then granular materials and the granular clay materials, which is granular materials with 35% or less passing of 0.075 mm, and the silky clay materials having more than 35% of passing from 0.075 mm. So we say that the how we solve this. Now we go for so some remarks. There is, according to this system, soil is classified into 8 major groups, A1 to the A8, and a soil group A8 is peat, means it is a very organic and very thin watery, and which considerable as a organic material. A soil is basically the soil is classified according to the table by proceeding from left to right and top to bottom, column by column on the table, to find the first group in which the soil test data will fit. Next, the first group from the left into which the test data will fit is the correct classification. The classification process stops at this point, regardless if another column further to the right can also qualify. Thank you for watching my video. Thank you very much.